I'm Bill Beasley, retired SPED Executive Director and current Treasurer of the Society of Piping Engineers and Designers. And the board has been long planning a series of webinars on automated layout. We consider this one of the up and coming frontiers of design technology. And so our first offering in this area is from PlantStream, which is based in Tokyo. And we have two presenters, Takuma Umida and Pooja Tayaja.
Hello, everyone, and thank you for joining today's webinar on layout automation with PlantStream's auto routing. So first of all, I'd like to thank SPED members for hosting this event and for giving us the opportunity to speak today. And we are truly honored to be part of this important session. So before we begin, we would like to introduce ourselves. My name is Takuma Umeda, and I am a business development manager at PlantStream. And I started my career as a piping engineer and construction manager at Osaka Gas Corporation in Japan. And in 2019, I moved to the US, where I worked in business development and at trading companies for 5 years, and gaining experience in international markets and business field. And I joined PlantStream last year, and I am currently responsible for the Americas market from Houston, Texas. Very nice to meet you. And Pooja, could you please introduce yourself as well?
Hello, everyone. Good morning, good afternoon, good evening from wherever part of the world you're joining this webinar. Myself, Pooja Tyagi, and I am from India basically, but presently putting up in Japan. And I'm working as a lead technical consultant with the PlantStream for the past few years. And I have a background of a piping and a layout engineers working in the different companies around the world. Like I worked in India as well as in Japan for the different energy sectors like LNG, power, geothermal, oil and gas, and the refineries. Today, I'm very happy to see you all attending this webinar, and I hope this could be a very fruitful session for you, and we could share some wonderful insights together. Thank you very much.
Okay, thank you, Pooja. Okay, so I would like to start here. And yeah, so in today's rapidly evolving industry, the automation is more critical than ever. And it plays a key role in enhancing efficiency, shortening the project timelines, controlling costs, reducing risks, and accelerating execution. So that as technology continues to advance at an incredible pace, adapting innovative tools has become essential to remaining competitive. Here is today's agenda. So firstly, I will briefly introduce our company and product. Then Pooja will demonstrate the software and show you how you can quickly create a 3D model in action. Okay, thank you. All right, so this is the company overview. So again, the PlantStream is a startup company founded in 2020 in Tokyo, Japan. And we provide automated 3D CAD solutions for plant engineering. And it was originally established as a joint venture between Chiyoda Corporation and Arendt. The Chiyoda is a Japanese EPC contractor, and Arendt is a 3D CAD provider for the entire engineering industry. But this year, PlantStream became a fully owned subsidiary of the Arendt while maintaining a technical partnership with Chiyoda. So although we are a startup, the PlantStream has already been implemented by around 25 companies worldwide, including both plant owners and EPC contractors across Asia, Europe, and Americas. Okay. So here, as you can see on this slide, the PlantStream is used in many different types of plants, including water treatment, chemicals, hydrogen, LNG, refineries, petrochemicals, FPSOs, power plant, and so on. And while PlantStream has earned the trust of many EPC contractors, plant owners also recognize its benefit in minimizing project delays and obtaining more accurate cost estimation in early phases of the plant design. Okay, and here the product overview. Okay, so before diving into the product features, I would like to highlight the key challenges we address. So there are two major challenges in this industry, the cost overruns and schedule delay. According to the industry report, 62 to 67% of oil and gas projects experience cost overruns and 50 to 78% face schedule delays. So we address these challenges with a unique approach. So these are the main features of PlantStream. The core functionalities are auto-routing and block patterns. The PlantStream can design 1,000 pipes in just 1 minute. And block patterns are preset templates of equipment and piping layouts. So with these features, designers can significantly reduce repetitive design time. Additionally, the PlantStream offers MTO and work volume generation capability, so enabling highly accurate cost estimation based on 3D models. And it also supports model import and export, allowing seamless integration into existing workflow. Okay, so again, the PlantStream enables the design of 1,000 pipes in just 1 minute and reducing design time by up to 75% compared to the conventional workflow. Okay, and this slide explains the scope of PlantStream. Currently, we focus on streamlining the early phases of plant engineering, such as feasibility study, pre-FEED, and FEED, or FEL 1, 2, and 3. However, and also the cost estimation. However, PlantStream also offers seamless data conversion capabilities to the downstream 3D CAD software, so enabling a smooth transition into EPC detailed design and beyond. Okay. And here I would like to introduce a key benefit of PlantStream with a real example of man-hour reduction. So this project involved a petrochemical plant unit with 60 equipment pieces and 220 lines at the feed level. While a conventional 3D CAD tool required around 560 hours, the same scope was completed in just 140 hours using PlantStream. So as a result, our client was able to save up to 75% in man-hour. Okay. And this is another key benefit. So in the conventional workflow, creating multiple layout options is often difficult due to time constraints in the feasibility or pre-FEED or FEED phases. However, the layout studies are very simple with PlantStream, and once the base layout is created, you can easily generate multiple alternatives by simply moving structures and equipment and running auto-routing. Through these multiple layout studies, you can compare the material quantities, functionalities, and efficiency, safety, and maintainability to ensure the most optimal design. Okay. And by creating 3D models from the feasibility study phase, the more accurate cost estimation can be generated. So this facilitates investment decision-making for plant owners and enhance the competitiveness of EPC contractor proposals and minimizes the cost overrun. Okay. And this slide shows the comparison between the conventional workflow and the new workflow with PlantStream. So in conventional workflows, The plot plans and general route studies are typically conducted in 2D during feasibility study, and also 3D modeling begins with existing 3D CAD at some point in pre-feed phase. But our approach is to replace this conventional early phase workflow with our solution, so improving overall design efficiency and enhancing productivity across the entire engineering process. Okay, so now I will introduce the import and export features. The PlantStream is an ideal tool for designing from scratch, but it also supports import functionality. If you have an intelligent P&ID, you can create the line list, cable list, and equipment list in a spreadsheet and import them into PlantStream to quickly generate 3D models. Additionally, the existing 3D model can be imported using FBX file, allowing the use of point cloud data or mesh model from existing plant. So this makes PlantStream applicable even for brownfield projects. And for export functionality, the PlantStream enables intelligent model exports for detailed design in Aviva and AutoCAD, and it also supports RVM and DWG file exports, making it possible to create 2D plot plans or review 3D models in Navisworks. And regarding MTO generation, users can create separate MTOs for piping and cables, civil structures, and making them useful for cost estimation. Okay. All right, so that would be it for a brief introduction, and we would like to move on to the demonstration. So Pooja, could you please take it from here?
Thank you, Umit-san, for your presentation. And let's start with the demo part. So let me know, I'm going to share my screen and let me know if everyone is able to see my screen or not. I hope my screen is visible to everyone.
Yes, I can see it.
Okay. So this is the PlantStream window, which we could see here. So on the right side, you could see there are the many elements like the structures, equipment, inline tied items, the block patterns, which I'm going to explain one by one in the next few minutes. So we have these structures, like a single pipe rack or the modules. We have the equipment structures, sleepers, T-post, platforms, double pipe rack. And so these templates are available in the PlantStream to support your activities. Next, we have the by far more frequently used equipments like the pump heat exchangers and the vessel stands in the form of the templates again. Then we have the block patterns, and because the auto routing is the main heart of the PlantStream, of course, if you want to customize the layouts or optimize the layout, then we do support the manual piping components also here, like these which are shown. So let's see how the modeling activities happen inside the PlantStream. Very basic, PlantStream has a drag and drop philosophy. Just to let you know, it has a Unity background, so it is a gaming software based product. So that's why the UI is pretty interactive and easy to use, and that's we received a compliment from many of our customers too. So I will drag and drop this pipe rack here. So you could see in this main view window, I have just drag and drop this. So this is a one pipe rack. The moment you add it, it will be added to the tree view also. Like every element, every software, these pipe rack will have the properties attached to it. So you can change the name IDs. You could rotate it from here. You could change the length and the dimensions. Now here I would like to mention, you will see these arrows also. So you could easily extend the width of the pipe rack. You could decrease it like this. And it's with the help of this gizmo, it's very easy to move the equipment around your unit areas. And because the PlantStream has a capability, you could import your DWG file plot plan. So the overlapping will become pretty easy to do once you are placing these elements. Now, the other is how you adjust these dimensions. So for example, I'm going to put up this dimension like 90 meters, width at 6 meters, number of the spans. So you adjust these parameters. Accordingly, the pipe rack dimensions will be adjusted, and you will see these are also adjusted here. And for the number of the layers, again, these are having a 4, you can increase it to 5 or decrease it to 3. So the number of the layers can be adjusted here. There is every element inside the PlantStream has some inbuilt calculation process also. So if you know these member sizes, so for civil and the steel specification, we support ASTM, BS, and Euro. So if you know these detailed members, like whether this is HLC, you could, based on your selection, you could specify what member size it is. Having said that, during the initial phases of the project, if we do not know, then we have this fit materials to the dimension. So this is a PlantStream inbuilt calculation process. So if you do the certain modification, you will see the member sizes will modify accordingly. So that's also one of the feature of the PlantStream here. PlantStream is actually a rule-based software where all not all, but many engineering rules, the standard engineering practice has been implemented in the form of the rule. And because of those rules, it helps to auto-routing to do its function seamlessly. Now for the pipe rack again, the more you play around the software, the more detailing and the more features it has. So for example, I'm gonna add this ladder here. You can add the stairs, the fireproofing requirement. You can specify the bay where you want to create the loops on which direction. So the expansion loop properties are there. Then we have this set side beam to half down. So you could set the members. Anyhow, if you want to adjust these dimensions, then we have for every layer, you could adjust these heights also, and the beam offsets here. And later, if you want to add on the platform, you could add on the platforms here. So every platform, again, if you want to adjust the heights, so you could adjust the height like this. If you want to expand them, then for every platform, we are having these extension properties also. And same goes for the each spans. So as I said, the more you go around the element, there are the n number of the parameters which can be adjusted by the user for even more optimization. This is the pipe rack here. The placement of the elements remains the same, except the few here and there, the properties changes. Then let's go for the equipment part. So in PlantStream, the equipments are divided into two parts. The one which are here, these are the general templates which are available like any other software. So again, I will just drag and drop one column here. So the equipment hierarchy is created. Again, if you want to add or modify the name, you could do that. You could change the orientation. Now, as I said, most of the elements have certain inbuilt calculation process. So same goes for the equipment also. We understand during the initial phases of the project, we do not have the equipment sizing available. Even if you are having the bare minimum information, for example, the diameter and the height. So if I'm going to make this diameter at 6 meters and the height as 30, so you will see the shape has gone a bit strange here. But the moment you click this update sub-dimensions, the system will recalculate all the sub-dimensions and the graphics will be created in the proper manner. And of course, if you know all these sub-dimensions, then you could update them here. Again, for the equipments, the nozzle, as I said, the UI is very interactive. You can simply use these gizmos to adjust the nozzle positions on the equipment, and more specific with the help of these properties tab here. You could quickly create this and then change the properties around here. You could rename them. So let's try to do it for one of the nozzle. I have picked up this nozzle here. And then if I want to change the size, I will make it to the 12-inch. Rating can be modified, whether that is the inlet or the outlet, you could change it, elbow projection height. So, and then if I'm going to make it as 35, so the nose projection can change like this. So that's how you modify or change the dimensions of the columns. If you want to add the platform, then platforms can also be added here. And for the foundation, shallow and the pile type information is available. Again, you can modify these parameters as per your requirement. This is the one set of the equipment which are created inside the PlantStream. The other equipments which are there inside the PlantStream, these are called as the block patterns. Now, what are these block patterns are? The block patterns are simple equipment plus the piping arrangement. So as I just mentioned before, PlantStream is actually a rule-based software. So wherever we felt there are the standard piping practices or the repetitive piping practices which are being followed, we try to create a template for them and providing the parameters for the users to adjust. So I have put one block pattern. So this is for the pump. You could select the number of the blocks it has, 1, 2, 3, 4. So I will make it for 3 like this. And then different options are available to customize the piping. So I have created this block pattern. Again, you can rename it, change the orientation. So I'm just gonna rotate it. Anytime, it's very easy to change because if there is a certain PNID changes, you could quickly modify these block patterns, the excess space like this. If you want to make even more, so the excess space can be changed. The header intervals can be modified like this. Now this is for the block patterns. Now let's see for the piping because as I said, there are the standard piping practices which are being followed. So here you could see instead of placing reducer, strainer, wall, one by one, you are getting a complete set of piping around these two pumps for the suction as well as for the discharge. And again, the properties which are attached to, you can modify the line numbers here. And there are the almost 8 to 10 parameters to optimize the route as per your PNID or the project specifications. You can change the size here. What type of the wall do you want? If you want it to be the globe wall, you could change it to globe wall, whether those are the horizontal or like whether they're single or the double. So I have made them double wall. You could change the positioning of these walls. So this is the one vertical, one horizontal like this. And for the strainers also. So as you see, everything we have tried to make it one-click operation based on the options provided inside them. And same goes for the discharge also. So here again, different properties are there. You could make it right or the left like this. You could rotate it. And then even if the joint type, if your joint type is different like 14, you will see these reducers are added automatically. And other than that, there are the multiple options to define the joint type. So if you want to make them independent, then each discharge of the pump will be the independent visual like this. So these are the block patterns. And similarly, we have the block patterns for the heat exchangers, for the control valves like this, and for the pressure relief valve. So you could see for the control valve also, we have the different inlet, outlet, BOP, bypass parameters attached to it. You can easily modify and customize the piping for them. So this was for the equipments which are available inside the PlantStream. Now, the second part of my demo is how we do the auto routing. So to put it in simple words, the auto routing is simply you are selecting the one starting point and the one end point of your piping. So here, if I'm going to select one starting point and the one end points, so I am selecting this. And for example, it is going to any of these factory limits. I'm going to click the route definition. So what is route definition? We are declaring the line. Whenever you take a PlantStream, it has a default database which is provided inbuilt inside the system. This is a SME-based database. That's why you could see there are the piping rating classes which are available. Having said that, you could easily customize the database as per your project requirement also. So we have a DB tool applications. So I'm going to put this 001, click OK, close. And then I will do the root assist, which is create the graphics. So you can see presently new graphics. If I do the root assist here, the one line is created in just 1 second of time. So here the line is created. And if I change the position of this equipment, once again you do the root assist, the line will be automatically rerouted again. Similarly, if I am picking up one more line, which is going from this nozzle to here, to the suction of the pump, then again you define the line numbers like this, close, and then do the root assist. So here, how the line has to be routed is coming from the default. There are several rules which are inside the PlantStream. So you could change those rules or modify those conditions to modify the PlantStream routes also. And then from here, if you want to create any of the branch connections also, so you could again define the line, of course, like this. So you could see there are the different forms of from end to header, nozzle to nozzle, multiple combinations based on your PNID. You could simply create these routes inside the PlantStream by just selecting the from and the to position. Now, this is the one method where you are inputting the line data one by one. But in the Umeda-san slide, you would have noticed we have the Excel import and export functionalities also. So same goes for the modeling of the line also. So here what which is called as a from to list. So this is from to list. Whatever you have modeled inside the PlantStream is also recorded in the form of this Excel sheet where the line information is there. If you download this template and based on your initial PFDs or PNID, you create this from to list information, even then you can import it back to the PlantStream and the bulk auto routing will be created. Now let me show you how this from to lists look like is. So this is a sample from to list. Definitely some very bare minimum information, again 5-6 parameters. This is the line number. What is the size? The pipe class specifications like this, and from where it is starting and where it is ending. And here you could see not only equipment to equipment, but line to the equipment, line to line connections, line to the control wall. So multiple combinations you can input here in this Excel sheet. And once this Excel sheet is created for you, you can import it back inside the PlantStream. So let me show you how it works. Definitely once your case one layout is ready with all the equipment and the structure arrangement like this, you could import that Excel sheet here. So this is the from to list I have imported. So there are the 66 lines which are imported here. Once this import is finished, you simply have to click, you would see all the line definitions are registered here, but no graphics. So to see the graphics, you simply need to do the root assist, all routes, and then there are the 66 lines. If you do the root assist all the 66 lines are routed within just 3 seconds. And let's see what is the quality of the layout which is generated because of these auto routing philosophy. PlantStream does not generate the routes just on the basis of the shortest possible route. But as I said repeatedly, there are the several engineering rules which are there. On the basis of those, these routes are created. For example, you could see the pipe to pipe space has already been taken care. On the pipe rack, where the lines has to be located. If this is the bottom tier, the process lines will be located at the bottom tier. If these are the utility lines, then these are located on the second tier. The large bore on the outside, the small bore keeps on decreasing like this inside the pipe rack. So the pipe rack space occupation is also judged by the PlantStream system. How the line is going radially downward, taking the branch connections from the side beam support, whether it has to be taken from top or the bottom, is judged by the PlantStream system. And as I said, this is the default routes which are created based on the PlantStream rules, but we have the several conditions which can be modified by the users if they want to improvise these routes. Just to show you example, for example, you want this branch to be rotated towards the upward. You could select from these options. I will click this upward, do the root assist, and then the branch will be created from the top. And same goes here also. If this line is routed outside the pipe rack, for some reason, if you want the line to be routed inside the pipe rack, remove this condition here and then do the root assist again. Wherever the available space will be, the PlantStream lines will be routed. And the benefit of the PlantStream is anytime you modify the sizes or anything, you do any modification, the adjustment is very fast inside the PlantStream. So if I am making this line as line size I'm changing, and if I do the root assist again, you would see it will try to modify or positioning of the line will be changed. So that's how the auto routing work inside the PlantStream. Then let's come to, before I jump on to the several exports of the PlantStream, let me show you another third part of my demo, which is the major feature of the PlantStream is, and where the users are leveraging to reduce the man hours of their project, is the creating the multiple layout studies. And what's that is, this is the case one layout which is created. So once you have created case one, your line information is registered with the PlantStream, and any moment if you modify those layouts. So if I'm gonna rotate this layout, so if this is here, let me rotate it by some 90 degree and then reposition it somewhere. And even for the pumps, instead of here, I want to make it a set of 4 pumps. I will try to rotate position. So I'm trying to optimize the layout based on my requiring by changing the position of the equipment. You could do this, and once again, you need not to reroute all the lines. You will see all the lines are disintegrated. You simply have to click one button, and based on the new positions of the from and the to, the lines will be readjusted. So you will see the another set of the layouts will be created, and then similarly you could create A, B, C, compare the MTO cost, and then you could decide which one is the best possible option for you. The last part of the MTO is whatever you have modeled inside the PlantStream, whether that was equipment, structures, and the PlantStream, you could extract the MTO out of it. And this data doesn't go waste because we are compatible with the different 3D softwares. So you can carry forward this data to your different 3D softwares like S3D, E3D, Plant3D, RVM for the navies, and FBX export, the DWG files, and that will be the intelligent data. So whatever the detail engineering modifications you want to do, you could do it there. And something similar we have for the ENI also. Whenever you are having these piping, the same type of the layouts, quick estimations and the layout adjustments can be done for the electrical also. So here we have this ENI module. Same, if you have the cable list information, same on the basis of from where they are starting to where they are ending, you simply import that list. So I'm going to import that Excel sheet here. Once you have imported this Excel sheet with the minimum information, like from where it is starting to where it is ending, you will see these cables like this. You simply will do the refresh all, and then the cables will be auto-routed. Of course, the space are reserved by the users for the electrical and the instrumentation. After that, the cable tray width as well as the cable sizings, cables location on the cable trays are adjusted by the system, and you can have the MTOs for that. And lastly, because we are running a bit of the time, let me show you how the MTO files look like. So not only the normal quantities you can extract from the plant stream, but you could have the work volume related information too. So here, because PlantStream has the capability, you could divide your model into the modules, into the areas. You can have those AWP packages, like you could extract the information based on the areas, line numbers. These are the specs. These are the elements. So you could see not only the pipes and the fittings, but the gate walls, flanges, different types of the walls, flanges, fittings, gaskets will be imported in the PlantStream MTO file. So these are the sizes. Of course, these are the quantities, mass, and then the work volume parameters like the inch meter, center line length, number of the well points, the standard lengths, insulation volumes will also be shown inside the plant stream. So that's how you create the plant stream model at a very initial stage. And of course, as we all know, the 3D gives you the better estimation and the better representation of your project. It is very easy to use it at the different stages and the different areas. And as I said, presently you could see these are only just the fittings which you could see. But if you want to optimize more and if you want to do the even more detailing, these are the walls and the several arrangements are there. You could add it to them. You could adjust their positions. The auto routes will be quickly adjusted based on this. So you could see the routing will be adjusted. So like this, there are many functionalities to support your piping activities to the feed and the pre-feed stages of the project. So yeah, that was the demo from my side. And if we have any questions and the queries, maybe we can take those.
So we have a number of questions now in the chat from the 29 participants. And so I invite Takuma and Pooja to go ahead and look at the chat, try to answer some of the questions.
Yeah, let me see. Okay. So yeah, thank you, Pooja. And that concludes our presentation for today. And yeah, next I would that we are happy to answer the question until end of the session. But before going to do it, I would like to share this one first here. Yeah, I just put some link to our like website and also some brochure and also the link to book like separate private meetings. So if you are interested, please feel free to contact us directly so that we can have a separate meeting as well. Okay, so yes, so that we have a lot of question here. And maybe it may be better to show how it works if we have some capability. So Pooja, can you share your screen and I will read the question and can you address the question?
Sure.
Yeah. Okay, then let me, okay. Thanks. Okay, the first question is from Kevin. So this is about the underground functionality. So the question is, how are underground pipe routing dealt with in Canada? In Canada, much of the water drains and some process utilities are run underground below the frost level. Yeah. Yeah, so this is done to avoid insulation and cost saving on support. No pipe racks are required. Yeah, and also like some are run in common trenches and others are run separately using directional drilling tech. Yeah, so
okay, so to answer your question, the PlantStream do support the UG routing also. Again, as I said, we have the certain routes which are already predefined in the system, but the user can also modify those conditions. For the underground piping, in the preferences, as you said, the lines run below the frost level. So we have these settings where for each underground piping, you could define these depth of underground POP. So for us, the default we have set as the 1500 mm. And just to let you know, we have the measurement units because the US mostly use the imperial unit. So we have the support for the metric as well as the imperial units here. You could choose based on your convenience. So coming back to the underground piping, as I said, the clash detection as well as how much depth do you want, it is already, you can define those. And whenever you are trying to route the underground lines, the piping will automatically take care of those UG clearances. So here, if I define it, you could see this is the AG and the UG. If I define this as a UG, click OK, close. So the line will be routed like this. And this BOP below the ground is maintained. You could see this is minus 1500 is coming from that particular setting. So I hope I answered your question. And here, because he particularly mentioned, like this is my demo was because we were short the time. That's why the demo I showed you is a standard demo where the stick build plant is used. But as Umida-san's slide already mentioned, we are pretty much compatible with the modules or the building type or the stick build type of the projects. Of course, it varies how much auto routing and how much manual adjustment will be required based on your project and the type of the project. But definitely, the PlantStream can be used even with where the pipe rack arrangement is not there. The next question is, does PlantStream handle nozzle loads and the equipment connection constraint automatically? So here I would just like to highlight PlantStream is we are a 4 to 5 year old company having quite a big customer base, and we are still rushing to develop this software with many add-on functionalities. So the load calculation is something which is there in the near future development plan. So presently the nozzle loads are not taken care by the system. The only properties which you can define for the nozzles are the size, rating, projection, and these. And based on the nozzle type, so if this is not a flange type, and if you do the root assist, the system will automatically has the capability to understand what type of the connection it has to be. So that's the only way you could do it right now, but the load calculation or any simulation is not happening inside the system as of now.
Okay, thank you. The next question is, how is stress analysis dealt with or integrated in the design, exporting and importing the change information?
Okay. So as again, I would like to presently because we are mostly used during the field feasibility and the conceptual stages of the project. So the direct interlinking to the stress software is unfortunately not supported right now, but probably the couple of version down, we are already working on it. And maybe few version down that functionality will be available. But because the information of the PlantStream can be exported to the other detail engineering software and that to intelligent data. So probably you could extract the stress analysis information from those software you can provide them. The only thing what you could do, like how does it deal if after the stress analysis there is some loop requirement on any of the line, you could define that condition here, and then the system will automatically take care of that loop. So that's how the more you define the conditions, the auto routes will be affected by that. So if, for example, I'm doing this 20 meter and on this pipe rack, I want the loops to be created on the right hand side direction and the number of the bay I write it 5. And once I do the root assist again, then the loop will be created based on that condition. So you could see the loop is created here. So it's a input of the condition from the user side.
Okay, thank you. So next question is how piping auto routing works with equipment or rock routed on other of 90-degree angles, like 15, 30, 50 degrees.
Okay, once again, this is something we are working on right now as the priority item. Presently, the PlantStream, the racks can be and the equipments can be rotated, but for the auto routing, we are still implementing certain logics and the rules so that the auto routing will also have its effects on those non-orthogonal pipe racks. But presently, it's not possible to create the auto routes on the non-orthogonal pipelines.
But we are under development for those like different angles, right? Yeah. Okay, thank you very much. And the next question is are loops automatically generated? The Pooja already showed it, but yeah.
Yeah, so just to quickly wrap it up, this question is the loops are not, as I said, no process simulation or stress analysis is being done within the system. The moment you enter the condition, then the loops will be auto-generated. So the user has to input the condition.
Okay, thank you. And next question is any of your customers from semi-fab or data centers, AI center, EPC company? Okay, so this I will answer this question. So AI center EPC company. Or could you do you understand this? What does that mean?
Okay, so yeah,
Yeah.
so presently, like we are, I don't think we have any customer from the data center or semi-fab industry using this software right now.
Thank you. Okay, the next is can you auto route piping within a point cloud to avoid existing obstructions? Yeah. Okay.
So for this, I will just show you one of the presentation. The PlantStream support the FBX import of the data. So as I said, if any of your point cloud data is available in the FBX format, you could directly import it inside the PlantStream. So here you could see this is the existing facility, which is imported inside the PlantStream. And after importing, if you were trying to do the revamp or the modification around it, that existing facilities will be considered as a collidable. Again, it's an option. You want to make it as a collidable or non-collidable option. You could choose it, but that's how the auto routes are generated in the existing facilities for the brownfield or the point cloud data. So definitely, if you mark it as a collidable, it will avoid the existing obstructions. So this is the example in front of you. By using the Preview 3D, we have created a certain revamp around the existing facilities.
Okay, thank you. And next is how does the cloud scan model like LFM or recap march in the model?
So as I said, any type of, though the PlantStream data can be translated to the different other softwares with respective their type and the patterns, but the only format which is supported inside the PlantStream to get imported is FBX, and more soon the Navy's data we can import it. So any cloud scan data, whether that is LFM or the recap, you need to convert it to the FBX module. So here this slide, you could see the FBX, you have to use any bypass software like Preview 3D or any other to create the mesh, and then you can import it inside the PlantStream.
And also we are currently under development for NWD format import. Yeah, NWD. Okay, and next question is there an option for sloped pipeline?
Okay, so for the slope lines again, this is one of the item in the our development list. Presently, the slope lines are not supported.
Okay. Yeah, so this is also the similar question, but like how this system functionality works in an existing plant with expansion project.
So as I said, if
Yes, same.
the existing plant data, if you have the 3D model, you could just convert it to the FBX and import it inside the plant stream. And if you
Okay.
do not have a 3D model, if you have a scan data, again convert it to the FBX and then or the navies and import it into the
Yeah.
plant stream.
All right, thank you. And the R weld counts reported.
Yes, the well counts are reported. Again, PlantStream has, you can see the number of the well points here. For each line number, the well points are reported based on the calculation method, which is inbuilt inside the system.
Okay, thank you. And the next is the as for PNID import is the from to data generated from common CAD software like Aviva or AutoCAD. In other words, is there already output interfaces available from the CAD vendors?
So, okay, so for the from to list, presently, why I'm repeatedly saying presently, because PlantStream is actually, it's releasing every 3 months a new version. So development is going at a pretty good speed and we are rushing to develop it as much as possible. So if you talk about at the moment, there is no direct interface which is available from Aviva or the AutoCAD Smart Plant PNID to directly convert it to the from to list. You have to use some macro outside the plant stream to convert into the from to list plant stream compatible format. But just to let you know, we are almost in the testing phase of a functionality where if you have your PNIDs, from those PNIDs, we would be able to generate the from to list automatically. So the user manual efforts will be reduced to create those MH from to lists by using some macro or outside the plant stream.
Thank you. So next is, does the MTO report provides the cut lengths or through lengths of pipe fittings, valves, and other inline piping components?
Yes, you could see it here, like these are the center line sum length. So for every component, you could generate this through length report, even the line wise or the component wise. So this is presently, you could see this is the line by, this is the component wise. For every component, the through length is reported in the MTO sheets for the components as well as for the pipes.
Thank you. And next is the does PlantStream replace conventional 3D design software?
Okay. So from the very initial of the presentation, we made it sure, like at present or maybe a couple of years, we are still focused on the feed feasibility and the conceptual layout studies. But if you talk in a long-term future, definitely we have a plan to do that. But as of now, our main potential or focus is to replace the conventional methods, not the 3D softwares.
Yeah, thank you. Yeah, rather than the conventional 3D CAD software, we try to replace with more 2D work or like manual work and try to automate those conventional workflow. Yeah, thank you. And next is, the time is almost running out, but here, and when a rack is scanned, how does the router use the points instead of its own model?
So when the rack is scanned, as I said, in PlantStream, every element has some properties and the rules attached to it. So if you want to utilize the future space of the pipe rack, presently you need to create a basic outer boundary like a pipe rack length, width, and the tier information you have to input inside the system so that it is overlapping your existing rack, and then the system will automatically take up those space locations because the clash arrangement and the clash mechanism is already there inside the plant stream. So wherever the existing pipes will be there, the system will not try to locate the pipe there. wherever the leftover space is, they will try to locate the pipe there.
Okay, thank you. Yeah, two more questions. So can PlantStream generate isometrics with bill of materials?
So presently isometrics again not supported because again, as we understood, it is not it is for many of the companies that may not be the deliverable during the feed feasibility and the conceptual. That's why once you translate the data to the other softwares, you could get the isometrics from there. Only the bill of material is supported right now, but we have something similar, a pipe length tooltip where you would be able to get the information about the pipe lengths and the fittings. So I would just quickly show you if this is the pipe which I have selected. So I have this tooltip, you will see, and you could easily extract this information from this. So we have something like this to extract the pipe information or the routing information to provide it to the process or the other departments.
Thank you. Okay, the last question. Is the PlantStream model exported to Revit, AutoPlant 3D, Hexagon S3D is for only reference purposes, or it can be used to continue the detailed design by using the S3D catalog or Revit families?
So here we, as I showed to you, we are presently compatible with the E3D PDMS S3D. Unfortunately, Revit is still not in this list right now, but AutoPlan 3D, S3D, E3D. And definitely it's intelligent data. It's not just the graphics or the reference, but it is the intelligent data which can be modified by the users in the respective software for their detailed engineering adjustment.
I want to thank Takuma and Pooja for very excellent presentation, and remind everybody that we're going to have another program in this series in June, and stay tuned. We'll invite you for that as well.